Okay, so when you have a fourth degree or a third degree polynomial times another third degree, you've got 4 terms that you're multiplying by 4 terms. So you have 16 terms that you got to keep track of. And I would say that really the only way, or the best way, there's not an only way, but the best way I can think of to keep track of all 16 terms is to do the box. Now the box might seem like a pain in some cases, but it's really going to be your best friend in this case. So you got your x cubed, your 7x squared, your negative 3x, and your plus 2. These represent the lengths of these sides over here. Okay, and so when you have a negative x cubed on top, x squared negative 1x, you can put 1s if you don't do, but minus 6. That just means then that when you look at this side times that side, you're multiplying those two together. What does that give you? Well, no, it gives you one term. X cubed times negative x cubed gives you x to the 6th power. Negative times a positive gives you the negative. Now, as we're just going to go across, it'd be like if we're doing the little rainbows across the top. You're just taking this x cubed times each one of these guys here. X cubed times x squared is going to give you x to the 5th. This one's going to be a positive. That was negative. This and that is a negative x to the 4th. And this is going to be a negative 6x cubed. So we can see the progression here. This was a 3, 2, 1, and nothing. But when we distributed the x cubed, each of those stepped up 3 powers from what they were originally. Now, we're just doing this next row here, 7x squared times each of these. This is a negative 7x to the 5th power. When you multiply the variables, the powers, you add the powers together. So this is a positive 7x to the 4th. This is a negative 7x to the 3rd. And lastly, it's a negative 42x squared. Now, eventually I'll point out some patterns here, but we'll just keep going with what we're doing here. This becomes a positive. Please keep track of those, the signs. A negative times a negative is a positive. This would be 3x to the 4th. This is a negative 3x to the 3rd. This is a positive 3x squared, a positive 18x. And lastly, the constant distributing here, we have a negative 2x cubed, a positive 2x squared, a negative 2x, and a negative 8. So, as I said, there's 16 terms. And those 16 terms are located at... What did I what? That's what I meant. Thank you. Good to change it now, right? Just so we don't have to refer back to it in the next video. Okay, so negative 12 is 2 times negative 6. Okay, so we have 16 terms. They're going to produce a handful of terms, but not 16, because there's a lot of like terms here. If you look around, there's only one term that's to the 6th power. And so we're going to just start there with that. Negative x to the 6th power is the first term that we will have here. Then if you look at the 5th powers, there's a pattern here. Diagonally speaking, you're going to have all of the 5th powers just lined up there. So you have negative 7, you have a positive 1, for a grand total of negative 6, x to the 5th power. So that pattern will continue. Okay, you look at that, there's 4 x to the 4th powers. Okay, I would look at the positives first and then take away the negatives. So there's 10 of them, minus 1 of them, which would give you a grand total of 9. So plus 9 x to the 4th. Now this is your biggest grouping here. You got all 4 of them. They're all negatives. So it's just a matter of adding them together. Okay, 2 plus 3 is 5, plus 7 is 12, plus 6 is 18. I'm saying plus even though they're minuses because they're all the same sign. So it's negative 18 x to the 3rd power. On to the next, we have our biggest number here, negative 42 and a positive 5. That would be a negative 37 x squared. I'm running out of space here. 18 minus 2 is 16, so that's a positive 16x. And lastly, the negative 12 that was only temporarily a minus 8 and never should have been. But that right there, if I were to plop it there in that spot, that's the answer.